Okay, so we talked about domains and we talked about poles and asymptotes and we talked about what a rational function is. Now we're going to talk about the first operations we're going to do on these, which are multiplication and division. This is not much of a rational function because the bottom has no variables in it, but it's just a good way to start. When we multiply fractions, we multiply the tops and the bottoms. That's how we've always done it, and we're going to do the same thing here. So this is x times x minus 3 over 5 times 7. You just multiply the tops, multiply across the top and the bottom, which is x squared minus 3x over 35. Like I said, this is not much of a rational function because the bottom has no x's in it, but it's a good way to just it's a good example for what I'm talking about here about multiplying. This one has x's in the top and the bottom, or a's technically. We can do it the same way. 5a cubed times 2 would be 10a cubed. And 4 times 5a would be 20a. And we're going to be simplifying these rational expressions in this unit. This is not wrong in any sense, particularly. It says multiply these things and you did, but I'm going to ask you to be simplifying your rational expressions before you're done with your final answer, which means canceling things that are factors of the top and the bottom. I see that 10 is a factor of the top and the bottom, which means I can 10 over 20 is 1 over 2. So this goes away and this leaves a 2 on the bottom. And a cubed divided by a, well, those both have a factor of a, so I can take, though that goes away and this becomes a squared. And I get a squared over 2. Yeah, that's right. That's a very awkward looking fraction because of where the 2 is. So let's just fix that up. There we go. That's a fine way to do this one. You can also cancel before you multiply. And in this problem, it's not that important to do it because the final expression is not that complicated. But sometimes it's going to be easier later. So I just want to show you guys how that works. You would do you look at, I'm going to rewrite it just so we have another example of it. 5a cubed over 4 times 2 over 5a. Sometimes you guys call this cross canceling or something. I don't really know if that's the right way to say it, but I'd like you to, this is the way I generally do it. I see, since everything's multiplied, the 2 and the 4, I can do the 2 and the 4 become a 1 and a 2. 5 divided by 5 is just, those just cancel out. You get 1 over 1. And 3 a's on top and 1 on the bottom, that goes away, and that 3 becomes a 2. And I get a squared times 1, which is just a squared. And I get 2 times 1 on the bottom, which is just 2. And that's the same answer I got here, which makes me happy. But again, the only reason I can cancel those things out is because they're factors of everything on the top and the bottom. There's no adding and subtracting in here, so you're pretty safe canceling things out. But when there is adding and subtracting, you have to be a little more careful. So we're going to do a couple of examples of that here. We don't have that much left in this, but that's how multiplication works. We can also divide these things. And just like we've always done with fractions, the way that you divide fractions is you multiply by the reciprocal of the second one. So you flip the second one over and you multiply. And so this is x minus 2 times x plus 1 over x plus 1 times x plus 5. Again, I'm just, now that I'm multiplying, I just go across the top and across the bottom. It says and simplify here, so I can cross off common factors. This is like x plus 1 times this and x plus 1 times that, so that's a common factor. And it's x minus 2 over x plus 5. Just like in the previous one, if you were you could probably skip this step a little bit if you wanted to. Once you got to after you flipped it over, like this, you can cross these off here. That's that cross canceling trick again. And that's going to work for you here because these things are all multiplied. So that's how we divide. It's not any different than dividing fractions normally. Just for funsies, if I was going to write the domain of this function here, it would be negative infinity to negative 5, -5 to -1, -1 to infinity. Because I have to use this one. Like I have to pay attention to both of these denominators, even though I canceled this one out at the end. You don't get to just ignore the x plus 1 on the bottom because you canceled it out later on in the problem. The domain is about the original function. What's the domain of this function? Not this one that showed up later. So you gotta, like, if I just looked at this one, I'd say the domain was like all the x's except -5. But for this one, which is the one I actually started with, I have to remove the -5, which I did here, and the -1, which I did here. You see that the -1, the factor that makes the -1 in the denominator here bad disappears. But it doesn't disappear from the original function, so you have to take it into account. Yeah, so this is like a lot of factoring and stuff coming up here, but I'm gonna run through these real quick. You guys can, if I go too fast, just pause it. The nice thing about the video is you can pause it and you can rewind it if you want to. So when I say sometimes it's easier to simplify first, that's again that cross-canceling thing I'm going to do. And I'm going to do all the factoring first if possible. So for example, this one, I see this quadratic expression here. I see the quadratic expression here. And I'm like, maybe I can factor these before I multiply. And you can. This one factors like x minus 5 and x plus 2. Minus 5, yeah, that's right. And this one factors as 2 -5s. So really this thing is x minus 5 times x plus 2 over 1. Because it's like just by itself, so it's over 1. And then x plus 4 is on top, and the bottom here we said was 2x minus 5s. And so I can see that there's a factor of x minus 5 on the top and the bottom I can cancel out. And I end up with, that's it, that's all I can cancel. I get x plus 2 and x plus 4 on top still. And one lonely x minus 5 left on the bottom. So this is what I mean when I say it's easier to simplify first. If you just multiplied all of these things by all of those things, you got this huge expression on top, it would be very difficult to factor. And you don't need to because it's easy to factor this first, and then you can see all the factors just laid out for you there. This one we're going to do in a similar fashion, but you may recognize this guy as the difference of cubes. That was a factoring pattern we saw earlier in our life. We used this mnemonic device, SOAP, to remember how to factor that. So it's a cubed minus 1, so it's 1 minus a. And then I do, so that's the same sign. Then I do I square the first thing, opposite sign, multiply them together for the middle term, always positive, and that's just this one. That's just a. It's a squared. This is the first thing squared. This is the multiplying the two things together is the second thing squared. Then there's an a to the 5th on top as well. And then the bottom is a squared. And I'm sure y'all recognize this as the difference of squares. And that's factored as first minus the second, and then the first plus the second. And now this is kind of the last trick, I guess, that we might have to do, which is so let's start with the a's. There's a squared multiplied by everything on the bottom and a to the 5th multiplied by everything on top. So I can cancel 2 out of the bottom and 2 out of the top. So I just get an a cubed. So I'm going to write a cubed here on top. This thing is not up here on the bottom, and this thing can't be factored. So it's just going to have to stay there. 1 plus a squared. And like the a plus 1 does not match with this. Certainly, those are not the same by any stretch. This has a negative a and that has a positive a, and this has a positive 1 and has a positive 1. So that's can't be factored. But this is the thing that I want you to pay attention to. These two. 1 minus a over a minus 1. And here's the thing. This 1 minus a over a minus 1 is equal to -1. They're like exactly opposites of each other. like a positive 1 on the top and a negative 1 on the bottom, and a negative a on the top and a positive a on the bottom. Like everything is exactly switched. And you could like try plugging in some values for a, and you'll see that you always get -1 when you do it. But for the purposes of like learning how to do this lesson, it might be good to just remember that if the terms are exactly opposite like that, you cancel them out and you write negative in front of the fraction like that. 1 minus a and a minus 1 cancel each other out, but leave behind a negative. Let me say that again. 1 minus a and a minus 1 cancel each other out, but leave behind a -1. And you can write it on the top, or you can write it on the bottom. You can't write it on both. I tend to write it in front of the fraction. It's just easier to do it that way, I think. So opposite terms on the top and bottom, let me say it again. Opposite factors on the top and the bottom cancel out and leave behind a -1. So that's where this negative comes from. And this thing that's left on the bottom is just sitting right there, a plus 1. That's it. So this is going to be something that you're all going to have to know how to do. So if you're like, I don't understand why that's true, make sure you ask me about it in class. Opposite factors in the top and bottom cancel each other out and leave behind a -1. All right, last thing we're going to do in this video is one more big, dumb simplifying problem. So it's a division problem, first of all. So let's divide and just rewrite it as a multiplication problem first. So I flip it over. Oh, I wrote equals. That was silly. Times a minus 2 and then a cubed minus a. So it doesn't look like anything can be crossed off now, but let's factor a little bit. This can be factored as quadratic. This can't be factored. It's just a binomial and there's no common terms. This down here, also binomial with no common terms. This is a binomial. When I say binomial, I mean a thing with 2 terms. This is called a trinomial. This one has just 2 terms, but there's an a in both terms, so I'm going to be able to factor that. So that this one, the top of this one is a quadratic that can be factored as a minus 1 times a minus 1. The bottom is just a plus 5. The top of this one is just a minus 2. I can take an a out of these and I get a times a squared minus 1. And it still doesn't really look I start that sentence over. It still doesn't really look as though anything can be canceled, but that is false because this a squared minus 1 can be factored as well. I got 2 a minus 1s on top and an a minus 2. On the bottom here, I've got an a, that a all by itself. I got this a plus 5. And a squared minus 1 factors into a minus 1 and a plus 1. So you can cross off an a minus 1 on the top and the bottom now. That was the whole point of that. So I get a minus 1 and an a minus 2 on top. The bottom is an a and an a plus 5 and an a plus 1. And just for funsies again, the domain of that function g of a, I'm going to write that down so we remember exactly what we're talking about. The domain of g of a, you have to go back to this step. You can't, after you cross these things out, you lose some of the things that make this original thing undefined. So you got to go back here. And there are 4 factors on the bottom. 4 factors. One of them is a. One of them is a plus 5. One of them was a minus 1. One of them was a plus 1. So if I set all these equal to 0, I get 4 values for a. I get 0, I get -5, I get +1, and I get -1. So these are all the values that make this expression 0, which means these are all the values that make this function undefined, which means I want to write a long, silly piece of interval notation that expresses all the numbers except those 4. This is going to have numerous parts. So the domain would look like this. I start with the smallest one, -5. So -infinity to -5. I put the -5 in here and I go to the next smallest one, which is -1. And I go to the next smallest one, which is 0. Then I go to the next one, which is 1. And then let's see, 1, 2, 3. That's all the numbers. So the next one just goes to infinity. So this is a pretty long one. When there's 4 things to remove, you end up with 5 pieces in your integral notation, which is kind of long. Again, this problem didn't say find the domain. It just said divide and simplify, but I did it just to demonstrate this can be done with any of these rational expressions. So that's dividing and multiplying and a little more stuff about domain for you guys. Like I said, we'll talk more about the simplifying, particularly the dividing out the opposite terms and leaving behind a negative in class. And we can talk about these two in class if you want to also. So I hope you enjoyed it. Bye.